Hello, everybody. Today's lesson is on section 2.1 in our geometry text on translations. So we learned a little bit about translations back in section 1.1 when we were exploring many different types of transformations. Some of them were rigid and some of them were not. And so we discovered back in that lesson 1.1 that translations are a type of rigid transformations, meaning that when you apply a translation, it doesn't change the size or shape. It doesn't change the orientation either. So all of the characteristics of the figure are preserved, and so that makes it a rigid transformation. So today's notes start on page 64. So go ahead and take out your textbook and open up to page 64. One thing that's different about the way that we're looking at translations in this section is that we're going to use vectors to translate our figures. And a vector, as it says here, has both direction and magnitude. So a vector doesn't have a location. You can move a vector like this, this vector right here, EF. If I move it over to here, it's still the same vector because it still has the same magnitude and direction. If I move it down here, it still has the same magnitude and direction. So magnitude means the length. So the length of the vector can represent something. When you get into physics or even when you get into pre-calculus, we use vectors to represent different quantities like speed or a force in pounds or newtons or something like that. And so the length of the vector actually represents some quantity. And so the two things that are important about a vector are its magnitude, meaning how long it is, and its direction. And so again, the location, the position of a vector doesn't make any difference. Vectors don't actually have position. They just have magnitude and direction. So the point where the vector starts is called the initial point, and where it ends, where we usually put the arrow, is the terminal point, as they showed in this diagram here. So we have the starting point. Initial is a starting point, and when something terminates, that's where it ends. And so the vector terminates at the arrow, the tip of the arrow, and that's called the terminal point. Okay, so what you see here in this box is how we're using this vector v to translate triangle ABC. So that means every point is going to move in the same distance and the same direction. So A moves to A prime, C moves to C prime, B moves to B prime, and those are all, if we draw all three of those arrows, those are all vector v. Okay, they all have the same magnitude and direction as vector v. And so in example 1, we're expected to transform triangle ABC by using this translation vector v. Okay, and so vector v goes 1, 2, 3, 4 to the right and up 2. And so if we make some copies of that and move them, or on your paper, you obviously can't do that if you're working on pencil and paper, but you can still count over 4 and up 2, and so that's going to give us our new location for C. So C prime is going to be here. Point B is going to go 1, 2, 3, 4 up 2. So point B is going to move there. And point A is going to move 1, 2, 3, 4 and up 2. And there is point A prime. So now our new figure is A prime, B prime, C prime. Notice that it's the same exact triangle, it's just been shifted to the right 4 and up 2. Okay, so that's what it looks like when we do a translation using a vector. Okay, so I'd like you to go ahead and try B. So in example B, you're transforming this trapezoid ABCD according to vector V. So go ahead and pause your video, translate that trapezoid, and press play when you're ready to see your solution. Okay, so this vector v is going to move every point left 3 and up 1, 2, 3, 4, 5. So point A, if we go left 3 and up 5, point A prime is going to be here, and that's vector v. Okay, do the same thing for point D, 1, 2, 3, 1, 2, 3, 4, 5. D prime, point B, I'm going to move to B prime, and point C is going to move to C prime, and so our new figure is A prime, B prime, A prime, B prime, C prime, D prime. Then on to page 66. Here's one more for you to try. Pause your video and try number 4. Press play when you're ready to see your solution. So this vector v goes left 1, 2, 3, 4, 5, and down 2. So point A, 1, 2, 3, 4, 5, down 2. So there's our vector v, and point A prime is here. Do the same thing for point C. And for point B. And so our new figure is triangle A prime, B prime, C prime. Back in section 1.1, we looked at how to write functions for different transformations. And so we can kind of see here that you can use a vector to translate a point. So if you have a point xy and you're applying vector AB, so a vector we use the pointed brackets like this. So if we use a vector AB, then that's going to move this point to x plus a, y plus b. Okay, so if this is our vector v, then we can write the function notation for any vector translation. Okay, so that's what example 2 shows, is that if we have these 3 points and we apply the vector 4, 6, that's the same as doing x plus 4, y plus 6. So whatever the x coordinate is, that's what you add to the x value. Whatever the y coordinate is, that's what you add to the y value. And so applying the vector 4, 6, you could go right 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6. So you could do it that way, or you could just do it algebraically and take the x coordinate and add 4, that gives you 1. Take the y coordinate, add 6, that gives you 4. And so that accomplishes the same thing. So you can go ahead and see if you can fill in all the blanks for example B by applying the vector -2, 3. Pause your video, press play when you're ready to see the solutions. Since we are subtracting 2, then that's x minus 2 and y plus 3. And so if you take the point 3, 0 and you subtract 2 from the x, that's 1, add 3 to the y, we get the point 1, 3. So 3, 0 starts here, and then it ends up at 1, 3. So this is, we'll call this point A and point A prime. And then this point, if we subtract 2, would be 0, add 3 would be 1. So 2, -2 ends up at 0, 1. And so this is point B and B prime. And then do the same thing for this last point. We'll call it C. And so that's 4 minus 2 is 2, and -2 plus 3 is 1. So it was at 2, sorry, it started at 4, -2, point C, and it ended up at 2, 2, 1. This original point is actually here. So we have C and C prime. So we have this little triangle ABC and its translation A prime, B prime, C prime. Okay, with that in mind, we should be able to do a problem like number 5 pretty quickly without having to work out any algebra or anything like that by applying this vector. We can draw our original figure. So 2, 4, we'll call that point A. Point B is at 1, 2. Point C is at 4, 2, so this is going to be in the way, so we'll put it over here. B was at 1, 2, and 4, 2 is here. Point C at 4, 2. Okay, and so now applying this vector, we're going to subtract 4 from the x-coordinate and add 1 to the y-coordinate. So point A is going to become -2, 5. -2, 5. So there's A prime. I'll do that. I'll do the image in blue. So there's 2, 5, -2, 5. So that's A prime. And then B, if we subtract 4 from the x, that's -3. Add 1 to the y, that's 3. So -3, +3. So that's going to be B prime. And C, if we excuse me, subtract 4, we get 0. Add 1, we get 3. So we're at 0, 3. So we did a vector translation, but we didn't really have to even draw the vector. We just did it all by subtracting 4 from the x and adding 1 to the y. We'll go ahead and finish off with example B. For this one, they give us the original figure, and then you're just supposed to write what is the vector that was used. So see if you can pause your video and see if you can figure out what vector translation. You don't have to fill in the rest of it, just fill in vector V. So when we go from point A to A prime, we realize that vector goes up 1, 2, 3, and over 1, 2, 3, 4, 5. And so we do the x-coordinate first, so it's 5 to the right and up 3, so that would just be the vector 5, 3. And that is it for today's lesson. Have a great day, everybody.